Alright, thanks for checking out another one of our videos. I'm back at it again, another Zareba 100 mile. And we get these things in all the time. You know, these things are not very well built. That seem to hold up very well long term. I've talked to lots of people that own these things that just freaking hate them. I think they like the power that they deliver, but they hate the reliability that's not there. These things run, you know, you might get 2 to 5 years if you're lucky. But we're going to dig in this thing and we're going to see if we can fix this thing up for a guy. So, but we work on these things, God, I don't know about weekly, but definitely monthly we get them in. So we're going to tear into it and we're going to see what we can figure out for it. The biggest problem with them is their transformers. That seems to be the biggest problem with them. They got real weak primaries on them, on the input side of the transformer. They get hot and go bad. And the reason why they go hot, or get hot, there's 2 reasons why. One reason, because they're not very well built. The other reason why is, you know, these things are, you know, you get a lot of power for the money. You know, people are always trying to save some money by buying as much power they can that they can afford. But trying to save some money. But what you do by doing that is you get a lackluster unit like this one that doesn't hold up well. And you see these fins right here. You got them on the front side too. The transformer sits right here, and it allows the heat come out of this thing. They have you want a lot of power for not a lot of money, but when you have it on too small of a fence, these things get hot because the transformer can't get rid of all its energy, and it goes bad. Well, I see one problem. Well, opening it up, these wires, I noticed they were all kind of white looking. They're supposed to be black. And you can see, you can rub off the stuff there, and it's got this chalkiness to it. And I look at that wire, and the connector is gone. And it's stuck to the capacitor, which is sitting right there. It's supposed to be plugged on right there. So that's one problem. So I don't know how that happened. Probably just wasn't making a good connection. And at some point in time, maybe they didn't crimp it very well whenever they manufactured it or whatever. So we're gonna put another connector on there. I mean, this might be an easy fix. But I'm gonna check that capacitor with my meter. Make sure it works good. Actually, I'm gonna do that before I plug it back up. Now, if you don't know how to check capacitors, I'm not sure if you can, if your meter can. You don't have to. I use a Fluke 115. We got 2 of them here in the shop. I use one, my dad uses the other one on his bench. But that's the meter we use. You don't have to use this meter, this brand. This is a good quality one. It's kind of expensive compared to others, but really well built. I've had this thing for about 10 years, and the only thing I've done to it, changed the battery about 4 times in it in the last 10 years. It takes a 9-volt battery. Good meter. But look at your meter and look for that symbol right above my finger, the yellow one. That's the symbol for a capacitor, not the white one. It's not ohms, not continuity. It's capacitance. It's a totally different reading. So that's the meter. That's the setting you need to look for on the symbols on your meter. So we're gonna turn it to NF, which is nanofarads, which is microfarads. So this is an auto range meter, so it will auto range to the rating of it. So it should read 50. Is what size this one is. Oops. And it reads 50.1, so the capacitor is good. So I'm plug this wire back on. All right, well, I can go ahead and plug it in, but I'm going to do just some quick tests on the things just to make sure that what I'm reading, that make sure there's nothing else wrong with it. So I'm going to go to ohms. That symbol right there by my fingers is an ohm symbol for checking resistance. And we're going to wide enough so I can see. And I'm going to go across the two black wires to the transformer, the input side. Should be 0. We're getting, should be 0 to 1. 0.3. And out here on these two brassings should be 10. 9.7. So the transformer is good, which is rare. So the transformer is okay on this one. So now I'm going to pull this little board out. This first board right here. This is a thermal protection board. We're going to ohm these things. There's two white resistors, a black one, and in between the resistors, there's a little silver thing right there, and one right there. That's your thermal protection things. Kind of like a fuse, but they're soldered in. At 7 point, it should be 7.5 or 7.8. That's bad. It should be like 0, so that little thermal thing's bad. 68. Read this one. That one's bad. So the thermal things have gone bad. Okay, so the 3 resistors are good, but the 2 thermal things are bad. So we need to solder those in. Well, good thing I didn't plug it in. Now we're going to check these 3 black things here. There's a big one there, another big one here, and another big one there. So we're going to check those and set back to this setting again, but this time we're focused on that symbol right there. That's for diode setting. And it's for checking diodes, but these aren't diodes or SCRs. They're basically 2 diodes back to back, reversed, or whatever you want to call it. That's how they are. So we're going to red in the middle, black on the outside should beep. Should beep and then stop, not beep and stay beeping. So that SCR is bad. Do the middle and up. So that one beeped and stopped. I'm going to do middle to other leg. That one's good. I'm going to do SCR2 as the bottom one. So red in the middle, black on the outside. That's bad. I'm going to reverse it. No, I don't need to reverse it. So we got 2 bad SCRs. 2 bad thermal things, and the wire on the capacitor was bad. Now, the only thing I'm going to do as well, I'm going to unplug these 2 black wires over here because I need to lift this whole board, pull it out, flip it over the back. Okay, nothing looks bad there. I mean, the board overall looks okay. This long board, usually, good portion of the time this long board looks good, front and the back side. Usually it is good. Alright, so now we're going to get the desoldering crap out. We're going to do some desoldering and soldering. I got to get some SCRs. Need 2 of those. There's 3 of them there, but 2 of them are bad. One of them's good. And I need my thermal protection things. We use a different style than what the Zareba ones use. We use these black square ones. I think they're just a better quality one. I need my desoldering stuff. Here's my solder. How's a desolder at? Oh, man, always losing something on this bench. Give me a second. Alright, so now we need to desolder. I think Zareba frowned upon repairing board. I'd rather you just buy the whole board. Which, go right ahead. These boards are about $25 roughly. And those trigger boards are about $60. And I think they frown upon guys like me repairing board versus just buying a new board. But they're not my boss. I do what I want. Alright, so now we're going to desolder the CRs. Come on. Yeah, this is fun to watch me desolder, I'm sure. Ow. One more. Come on, get on there. So pull this one out. Pull that one out. Since they're both bad. I'm hoping that something else is bad in that board. I guess there could be something else wrong. Well, let's check one more thing. That's good. That's good. All right, the resistors and the actual little diodes that are on there, those are all good. So now we're going to put these in there. I'll solder those in here in a second, but I'm going to put these in first. Space those apart. Oh, I've got to pull them out first. That one broke. Alright, now we can put it in there. So you get that about centered and bend the legs to where they go down the little holes. Right, same thing here with this one. Alright, now we can solder everything up. I need to snip the excess out. All right. Now we're going to plug that back in. I could change the transformer. I mean, the transformer's not going to last. It tests good, but you know, he might get another 6 months. He might get another year or two out of it. I don't know. But right now the transformer tests good, so I have no reason to change it. Looks good. The bulb's not burnt out. Put 2 black wires back in. Oh, shit. I have to solder SCRs. God damn it. Solder those 2 things. That ain't gonna work if I don't solder those things in. Lucky those don't take that long to solder. I can do that real quick. Alright, plug this stupid wire back in there, and this wire right back in there. Make sure that their board's sitting down where it's supposed to be. Wires need to go up there. Capacitor. Actually, hold on. Let's. That's starting to burn up right there too, so we're going to take. That's starting to burn up there too, so we're going to take that off. Oops. I'm going to do that again. There. Trim on a new one. All right, see what happens. Please don't blow up. There it goes. Let's put the tester on it. Getting about 8,000 volts out of it. Well, the transformer is good right now. I'm not going to bother changing it because it's good, but that's the Achilles heels. I imagine next time it comes in for repair, that's going to be bad, and one of these is going to be bad. But these are kind of expensive for me to change out. I don't use these factory transformers. I use a custom built one inside these things, and they're a little bit more expensive, but they're a lot better built. So I'm going to leave it alone. So this thing's good to go. Capacitor's good, board's rebuilt. Everything's raring to rock and roll. So now we're just going to put it all back together and call it done. Make sure all the screws that might have fallen out are out of there. There's 4 of them here. There's 1, 2, 3. Get this put on there first, and we'll shake it around, make sure all the screws are out of it. And all the screws are gone out of the case, or out of the inside of the case, so that's all good. So we're just gonna put this back together, call the customer up, give him a price on the repairs, and I imagine he'll fix it. I'll just kind of give him a heads up, because there's 18-month warranties on the repairs, but the transformer is the biggest problem child part in these things. And right now his is still good, so we're going to leave it be. I don't want to, whoops. I don't want to change something just to change it, just because it, you know, I know it's a common failure point, but it just adds expense to the repair. I'll give them an option. I'll probably wait on sending it back, you know, until I call them, of course, but I'll give them an option. You want me to change it now or change it later? You know, so we'll see what he wants to say. But anyways, hope you like this video. Hit that thumbs up. I got a bunch of videos out there how to test and repair these a little more in depth. This was a pretty quick little run through. But just type in how to test a Zareba 100 mile or testing a Zareba mile, 100 mile, whatever. I've got, I don't know, 5, 6, 8 videos out there just on these type of things, more detailed repairs. You type in upgrading a Zareba 100 mile transformer. I got a bunch of videos on that. Or a Blitzer 100 mile upgrade transformer thing. I've got 450 videos on YouTube right now, so there's a bunch of videos on all sorts of things. But hit that thumbs up button, hit subscribe to the channel, please. Appreciate it. Until next time, see you guys later on.